Hey YouTube, I'm Andrew, a manager at a medtech startup and ex-consultant at multiple early stage startups. Today we're going to do some Kotlin programming. If you like some of this content, then please like and subscribe so it helps the channel. But we're going to build our own maze solver. So what I want to start with is actually building a display of the maze and doing that all in Kotlin. So we can jump in and get into coding it here. So we'll start a new project here in IntelliJ and we'll call it, I don't know, maze solver. And what I want to do is create a new file right here and we'll call it main KTS. So KTS is going to let us have a script so we can just write all our code in this one file instead of having to break it up into many. So I want to do that, and I don't want to add it to Git yet. And let's start with maybe a cell. So like a data class where we have a cell, and maybe the cell has like our top, bottom, left, and right to keep track of the walls of our maze. So let's do, we'll have to modify them. So we'll do a var and do top. It'll be a Boolean for whether there's a wall there or not. And I want to do this a few times. Do bottom, left, right, and maybe we want to do like a visited. And do that as a Boolean. That way we know whenever we are building our maze, we want to make sure that the walls all are correct. So we'll need something like this whenever we're building that. What is this angry at us for? It's angry, oh, because it doesn't have a runtime. So let's add that. And we'll start with creating a new class, call it maze. This is where most of our stuff is going to be, and we can do a function in here that's print maze, and we'll need to instantiate a new grid size for the maze. It could be an integer. How do we want to do this? We can do a maze here, and this is gonna be like an array of arrays of our cell. And if we do maze, we can create a new one of these by doing array grid size, and that'll take a lambda where we can initialize more information in here, and we'll take grid size, so we'll make it a square. We won't do anything crazy here. So it'll be the same length and width. Array needs to be spelled correctly. And in here, I believe you can do an initializer here. So shorthand would be like this for the lambda. You could do something like this, but I don't think, yeah, it doesn't need that information. And cell needs some defaults. So we can do all of these to true except for visited. So we'll have walls all around there. And then printMaze can be there. And then we'll run the thing by saying maze, printMaze. And maze can take a 3, so we'll do like a 3 by 3 to get started, and we'll figure out this printMaze function. And if we can get that in a good spot, then we should be able to generate our maze. And that's probably where I'll leave off for today. And then from there, we'll implement the solver algorithm to go through the maze and figure out how to solve it. All right. So from here, I think we want to loop. So we can do like I in 0 until, which this is a nice Kotlin thing to do a range. You do 2, I think you can do until here, and we'll do grid size. And we don't need this to be public, we can leave it as private. And printMaze isn't going to return anything, but we do need to loop over the nested array in here. 0 until grid size. So what we can do is maybe print x's if like the right hand neighbor is available. And what I'd like to do is also have like a border around it. So if we did a print with some x's, then this should give us our top row. And we need a bottom row. And we may want to make this a little bigger, like, I don't know, we could do double the size, see how that looks. That way, you know, the x's that we have on the bottom and on the top will box in our array, or our grid, I should say. And then if we're on the first row, or I'm sorry, if we're in the first position, then we want a left-hand column of x's. So we can do an x there. We need a divider here. And we'll need a divider here. So we have our left-hand side printing. Then we need to check if our maze, where it's I and J, if that's the right, yeah, the right side, if that is there, which means there's a wall there, then we want to print an X. So the space is going to be like our cell, and then the X is going to be the wall there. And we'll need an else statement. And we want to have the same number of spaces, so we'll have 2 spaces in here instead of a space and an X. Alright, let's see how this looks. We'll run this, see what our grid looks like here. And we don't see anything. Oh, there we go. Not bad. That's not bad. So we have a 3x3. So this is our actual cells in here. We need this to be a little bit longer, so maybe we'll do it ×3. See how that one looks. All right, that should give us plenty of room. So if we want a right-hand side border, so if we do, actually it is J, and J needs to be grid size -1, and I think we need a space there. We'll see if this prints pretty nicely for us. All right, that's not bad. That's not bad at all. All right, so we have a grid. We have a box around it. So left-hand side, right-hand side, top and bottom, and then our 3x3 in the middle there. So we have a good base to start with. Now we want to generate our maze. So we could write like a generate method, and we want to create the function like row takes an integer, column, integer, and this can be at the bottom here. I like to have my private methods at the bottom. Alright, so now what we can do is we will want to go over, and this is where the visited comes into play, because we want to be able to generate, like we want to basically tear down all the walls so that we can knock down a path for us to solve whenever we're trying to solve the maze. So we can start with the top left and do the row column, and we'll say visited is true. Then from there, we want to make sure we go all around each of the cells. So we can say that the maze with row and a column visited, and we want to go all the way around. So maybe we'll start with row +1 or row -1 or this. Oh, did I grab? No, we need to close this. All right. So let's break this up a little bit. Oh, I did grab the closing parenthesis. I did not mean to do that. All right, let's break this up so it's a little bit easier to read. Because we want to do row and column +1 -1. So here, row, column +1, column -1. So we're checking all around the cell. And while we're doing that, just do another loop in here. We may not need that. Yeah, let's kill that. Val, we want to pick, we don't want it to evaluate in each of the same orders, so we'll do a random choice. And one way you can do this in Kotlin is do what's called next int, and then give it a value like until 4. So we want to pick one of the 4 values. We'll import this. Yeah. And that'll give us a value between 0 and 3. And then we'll do some if statements to check that. So if random choice is 0, then we'll do a thing else, and we want to have this for each one. So oh, come on, what are you not, why won't you grab the thing? All right. Random choice is 1. Random choice is 2. Random choice is 3. So, oh, we could replace that. That's fine, we'll refactor that in a minute. So we'll just pick one and say that that one can be the maze row. Let's see, we'll do the column +1 visited. And then we'll do similar thing here. And we will do row here maybe. Essentially we're wanting to put our logic in each of these if-else blocks. And so we'll do a similar thing. Maybe this one will be -1. And then this last one can be -1 on the row. So this first one, we'll need to update the walls for the top and the bottom. And then what we can do is we can call this function again. So we'll do recursion here, and that way we travel to all of the different neighbors for a cell and knock down all the walls. So like I said, we want to do top and we want to do bottom. So maze, do this thing, and both of these are going to be false. And then we'll break, and we want to call our function with row and column -1 here. So, oh no, I'm sorry, this is +1. We want to match this. So this will be row, this will be column, and this will be column +1, because we want to do the top and the bottom. Perfect. So we'll do something similar for all of these. This next one, we're gonna do row 1, and this is gonna be the left and right. And we have row +1. That should be fine. And then we want to call this with our next neighbor. So let's grab that. That's our left and right. And then we want another top and bottom here. But for column -1, that should be fine. But we want to invert it. So this is going to be top. This is going to be bottom. And that should work fine for us. The last one, we'll do another left and right. And actually this one needs to be right, and this one needs to be left. That way we're knocking down the correct walls. So we're knocking down the right wall and the left wall for that neighbor. It is essentially what we're doing here. So this one, do subtraction, and we want the left wall and the right wall of our neighbor. That's perfect. What I'm noticing here also is we need to check the bounds. Make sure we're inside the grid. We should be able to do that in its own function. Maybe like a within bounds function. Takes a row and an integer column as an integer, returns a boolean, and it can just return true, and if some criteria, then it's going to return false. So we want to make sure that row is, so if it's less than 0, this is bad news. Or if row is greater than grid size, that's also bad news. Or if column, same thing. If it's less than 0, we got -1, that's a bad index. Or if it's greater than grid size, that is also bad. But we won't actually get to grid size, so let's make this equal instead of greater. And that should do it for us. So we can use this within bounds. We'll need to use it in all the places, I believe. So here we'll do a within bounds check. And we'll essentially want to do this. Replace these with a comma. And that's a good check. That will need it. That will need it. That will need it. And we'll grab this within bounds. We're going to need it on all these lines. And we should be able to do a little bit of nice copy pasta. This one is going to be row column +1. There's probably a much cleaner way to do this, but to get us started, this I believe should work for us. Alright, perfect. So we're checking our bounds and we're doing the +1 -1 on column and row. We need to do the same thing here. So we'll do again, row column. Make sure we're staying within our bounds. That should be good. Alright, now we're in here within bounds. Alright. We're getting closer and closer. After we have these all changed, then I think we are good to try and run this and see if we get a nice maze generated. Alright, and row, column right there. Make sure we have within bounds on all these. That looks great. Alright. We're calling the generate method here, which is going to mutate our array for our maze. But if we want to do this more functional, which is kind of what Kotlin guides you to do, then we could clone or like create a new one or map over it. But I think this is okay for now. Alright, so let's run it. Let's check it out. Alright, this is looping over some stuff. Okay. That works. Let's see if we get some more random mazes here. Nice, okay. I don't know how that one's solvable. Maybe that's a bad example. Alright, that looks good. Yeah, okay. Well, from here, we can take it and we will implement the solver algorithm next. Come back and check it out, and we'll see you next video.